Hello, today we're going to be solving leetcode 3068, find the maximum sum of node values. So the way the question works is they give you a tree represented as edges, and then they give you an integer k, and then they give you nums, where nums is the associated value with each edge. So node 0 has value 1, node 1 has value 2, node 2 has value 1. So they let you perform an operation any number of times on the edges of the tree, where you can take any edge and you can XOR the values connected by that edge by k. So in this case, you could take this edge here that connects node 0 and node 1, take their values, which are 1 and 2 respectively, and XOR them with k. So you'd end up with 2 and 1. So this question has a little bit of an interesting trick. It doesn't involve DFS or BFS or anything along the edge of the tree. Instead, you can just look at some examples. So let's look at just a straight line, and we'll just have this be our tree. So these are the edges, and then these are the values, not the actual node numbers. And we'll just say our k value is 3. So in this case, you'll notice performing the operation on either edge here actually would hurt the overall sum. If you perform the operation on this edge, you'd end up with 2, 0, 1. And that decreased the overall sum of the tree because before these added a 4, and now they added 2. But if you perform the operation again on this edge, then you'll notice you go back to having a 3 in the middle, and then you'll have this extra 1 over here. So what just happened is you took this intermediate node 3 and you XORed it with k, and then you XORed it with k again. And k XOR k is 0, so you basically just did 3 XOR k XOR k. These canceled out, so you just still have 3. And also what you might have noticed is that the only two numbers that would actually benefit from being XORed with k in this tree are this one over here and this one over here. And that's going to actually be kind of the strategy for solving the entire question, because it doesn't matter how many nodes are in between any two values that benefit, because the two values that are on the end of a path are only going to be XORed with k once, but every number, every intermediate node in the tree is going to be XORed with k twice. So the k's will cancel out because they're involved in, the k's will cancel out because k XOR k is 0. And since these intermediate nodes are involved in two operations, they're going to not actually have any side effects from being XORed with k twice. The only numbers that will actually change along the path are the numbers on the end of the path. So, for example, if we were to go back and, maybe our example was 1, 3, 3, 1, then the same thing would happen where you'd do the XOR with k. You'd end up with 2, 0, 3, 1. And then, these two numbers are still our intermediate numbers. So we'll perform the operation there. You get 2, 3, 0, 1. And then now do this last edge, 2, 3, 3, 2. So the only numbers that actually change are these numbers on the end. One example that might trip us up a little bit, though, is when there's a leftover number that might benefit. So let's say we have 1, 3, 1, and then 1, and k is still 3. Then in this case, as we saw before, you could look at this path here, and you want to take the 1 XOR 3 and the 1 XOR 3. So this would become a 2, and this would become a 2. But then you have this leftover 1, and there's nothing you can actually do with this 1 to XOR with anything, because there's no other node you could pair it with that would also benefit from XORing it with k. So you have to watch out for these leftover nodes. Another example that we might have to watch out for is this example, where let's do a different k. Is this example where let's say k is like 6, and then we have two nodes. We have a node that's, let's make it 4 connected to 0. So in this example, one of the nodes benefits from being XORed with k, because obviously 0 XORed 6 becomes 6. But this node doesn't benefit from being XORed with k. 4 XOR 6 just becomes 2, because this is 4 in binary and this is 6 in binary. So XORing them would become, it would just be 0, 1, 0, which is 2. So the question becomes, when you have this situation where this node increases and this node decreases, then you have to do a little bit of a trade-off. You have to say, will this number benefit more from being XORed with k? Then this number will hurt from being XORed with k. And in this case, it's true, because this has a +6 effect, whereas this one only has a -2 effect. So that's an overall benefit to your sum of +4. So in cases where we have like a leftover node that might benefit from being XORed with k, but there are no other numbers that might benefit, it still might be worth it to find some number to XOR with k, because the possible gains are bigger than the costs of losing a little bit from one of those like other numbers that don't benefit. So that's it for the drawing explanation. Let's hop over to the coding. So as you might have noticed, the edges don't actually matter. We can just replace it with an underscore. The only thing that matters is the fact that you can connect any two nodes in the tree via some path. And since it's a connected graph, there's always going to be a path between any two nodes. So we actually just have to look at the values of nums. So let's create a couple of variables to solve this. Let's keep track of the number of operations we've used. And then let's also keep track of a difference variable. And this is going to help us with the leftover nodes to know if we want to perform the trade-off that we mentioned in that last example with 4, 6, and 0. So now we just have to iterate over nums. And let's check and see if this number is going to be benefited by XORing with k. So if nums of I XOR k is greater than nums of I, then that means XORing nums of I with k is good for the sum of the of all the node values. So let's increase our operations because we want to perform an operation. And then let's see how much it helps us to, or how much it would hurt us, sorry, to not actually XOR this value. So like if we have to leave a number out in the final sum, which number do we want to leave out? So diff and then nums of I XOR k minus nums of I. So this ultimately will tell us like if we have a leftover number and it doesn't have another node to be paired with and we have to leave it out, we want to leave out the number that would benefit the least from being XORed with k. Yeah, and then finally, let's just take our num and let's XOR with k because it helps that number. So if it doesn't help the number to be XORed with k, then we want to know how bad it would be if we did XOR with k. Because if there is a leftover number and it benefits a lot from being XORed with k, but it doesn't have anything to be paired with, then we want to know what other number in the tree would not be so bad to XOR with k if we really had to. So in this case, it's nums of I minus this because nums of I is bigger. And then finally, let's check and see if we have a leftover node that doesn't have a pair. So that would mean that if ops mod 2, then there's an odd number of nodes that would benefit from being XORed with k. Then we're going to go ahead and we're going to return the sum of nums minus the difference. Otherwise, if there are an even number of nodes that would benefit from being XORed with k, then we can just go ahead and return the sum because all the nodes had some path between each other that would be valid. So let's check and see if this works. Okay, submit it. Okay, that's how you solve leetcode 3068. The time complexity is just O of the number of edges, or O of the number of nums, or nodes, I guess. and then the space complexity is just O of 1 because we only use 2 variables. So thank you for watching.